Gating inverses. You should have this in front of you. The first thing we take a look at is you notice you have two tables and you've got a coordinate plane. Well, let's come down here and take a look at number one. So what number one tells us to do is look at the ordered pairs in each table. And there's a pattern to this. So let's take a look at the ordered pairs in table one. All right. So we take a look at this one. Now let's come in and look over here. What do you think is happening? Take a look at them. Okay, well to me it looks like we just reversed x's and y's. So let's come into this one. If we're true, then my 7 and negative 2 should be switched. Sure enough. And if you look at every one of these, what we've done is we have switched the x's and y's. So what patterns observed? X and y values are switched. Okay. Now these notes are not going to be on this page. I would do them on the back, and I will check for these. Okay, so they'll point to a functional inverse. Typically, let's say you've got y equals to 200 x. X is days. Y is money. So if I ask you to tell me how much money you're going to have in 4 days, right? Well, we can draw a graph on this. And it should be 800. It's going to look something like this. So one thing is obviously just to plug in 4 for x and calculate. It's going to be 800. The way you're doing this graphically, of course, is you're coming in, if this is x and this is y, you come into 4, you find where it intersects, and you go over, and you read your y value. So when x is 4, y will be 800. When x is 3, y will be 600, and so forth. Okay? Now, let's turn this question around. You got arrested, and you're going to need to post bail. So how long until you have $1,000? All right, this is how long you're going to have to sit in jail. All right, well, what we do here then, again, you turn this back around. Only here now, because I don't have that, that's what I'm solving for. What I do is I have to come over to my 1,000, where it will intersect, and when I come back down, that will be at 5. Okay, so what we're doing with the inverses is we're switching the x and y values. For a normal function, you're given an x and you solve for y. For an inverse function, you're given a y and you're solving for x. So you're turning your x and y values backwards. Okay, you're flipping them, or you're flipping your dependent and independent. And that's basically the trick to doing inverse, and that's the big idea behind all of these. All right, and so that's what we found here. When you take a look at it, we flipped, if this is our normal function, we flipped the x's and y's. So table 1 is going to be our function. And table 2 will be our inverse. So on this one, for instance, you would come in, I know when x is 0, it's going to be -1. All right? Now, okay, when what x value will y be 6? Okay, well, it's this one, right? Well, when you come over here, you'll notice that what was my y value is now x. So when that is 6, it will occur at 4. All right? Now you can also see we've got a few problems here, and that I have repeated values. Okay. So the next thing, it tells us to plot the points in order. So I'm going to do function 1, I'm going to do in blue, 5, 3, and then I've got -2, 7. I'm going to connect those. So we know automatically this is a continuous function. I got 0, -1. Then I go to 2, 4. And then I go to 4, 4. And then I go to 4, 6. Two, 4, 4, 4, 4, 6. And then I go to 5, 7. Okay, now you should be able to spot right off the bat, and you can get it from here too, that this is not a function because I have repeated values. Okay, so now I'm going to come back over and I'm going to plot this table in red. So I'm going to have 3, -5, and then I will have 7, 7, -2, and I connect those 2 points. And I'm going to have -1, 0. And then I go back to 4, 2. And then I've got 4, 4. And then I go to 6, 4. And then I go to 7, 5. Okay, so let's take a look at this. Now we know how these are interrelated. You switch the x and y values, right? Okay, so the question is, how are the graphs related? What transformation occurs? Okay, we know we flipped the x and y values, which means that table 2, and this is the answer to number 3, is a reflection, you should remember this from geometry, of table 1. All right, so then it says there's a line of symmetry that runs between these two things. And it's right here. You were supposed to do it in dashed, and I didn't. I did it in green. What's the equation for this line? Well, you notice it goes through 0, 0, 1, 1, 2, 2, 3, 3. So the equation for this is y equals x. So what this means is that my inverse is a reflection of my original function across the line, y equals 2.